Introducing the SCX Smart Replenishment Orchestrator, Shelf Life Edition, your powered solution for optimal inventory management. In today's fast-paced, complex supply chain environment, making optimal replenishment decisions is crucial yet challenging. The SCX Smart Replenishment Orchestrator is an advanced reinforcement learning agents platform that autonomously orchestrates these decisions while factoring in shelf life expiry, production schedules, inventory levels, transit timelines, and demand forecasts. It continuously learns and adapts to craft the ideal replenishment plan. We'll dive deep into the orchestrator's robust features and see how it optimizes replenishment under 3 different strategic objectives: revenue optimized, fair share, and priority optimized, all while considering shelf life expiry. We'll explore its intelligent demand forecasting, constraint-based modeling, and user-friendly interface that puts advanced optimization at your fingertips. With our intuitive user interface, allows you to see the results of autonomous replenishment runs by selecting from hundreds of shipping locations, distribution centers, and millions of materials. You can also choose the review period and one of 3 strategic objectives: revenue optimized, which maximizes total revenue by choosing the best shipping plan for each distribution center and material. Fair share, that distributes inventory proportionally based on distribution center needs and priorities. And finally, priority optimized, which prioritizes high-priority distribution centers first, then fills remaining demand at other locations. For the purposes of this video, let's walk through a real-life example using our orchestrator. We will execute online the replenishment orchestrator to understand what happens, remembering that in normal day-to-day operations, the application is run autonomously in background, automatically selecting the best optimization model for each stock keeping unit, supplying plant and distribution center combination. First, we select our supply network nodes. For shipping locations, we'll choose the Chicago Production Center, Atlanta Manufacturing, and Denver Production Hub, our key manufacturing sites. Next, we select our distribution centers: Northeast Regional Distribution Center, Southwest Distribution, West Coast Center, and Midwest Distribution, covering our major demand regions. Finally, we pick the materials such as SCA 10012, CBB 20050, and CSC 3036. In the orchestrator, you have the flexibility to set the review period, which determines the interval over which inventory levels at the DC and shipping locations are assessed or reviewed considering shelf life. The interval period, lead time, and average demand in the review period is used to calculate the target stock level at the DC. In this demo, we'll set the review period to 5 days. In the background, the system will automatically select for each material one of the 3 optimization modes based on rules provided by the business. For demonstration purposes with our network set, we choose to optimize for maximum revenue. Now the orchestrator will create a replenishment plan that drives the highest total revenue, prioritizing the most profitable stock-keeping units and distribution centers while minimizing spoilage by optimizing remaining shelf life and expiry dates. With our supply chain network set up and the optimization type selected, it's time to put the Smart Replenishment Orchestrator into action. When we click the Run button, the system springs to life, processing vast amounts of data and complex algorithms to generate the optimal replenishment plan. Here we get all the shipping details table displays all the critical information, including distribution centers, batch numbers, shipping locations, replenish quantity, lead time expiry date, and many more. Let me walk you through our first scenario, which demonstrates how our Smart Replenishment Orchestrator handles short shelf life products. We have batches ending in B001 and B003 for the same material that expire within just 6 days. This creates a narrow window where we must honor product quality while meeting customer demand. Rather than blindly shipping to all distribution centers, our system intelligently evaluates each DC based on lead time. It only allocates inventory to locations where products will arrive within the quality window. The results speak for themselves. Northeast Regional DC with 1-day lead time will now be fully replenished while arriving with 2 days of shelf life remaining from its expiration date. However, for West Coast Center, location plays a huge role. With 4-day lead time, even though it has 6 days shelf life, Given its expiry date, the system knows, now that it will arrive expired, flagging our system to not replenish. The system makes these critical quality decisions automatically, ensuring customers always receive fresh products. The second scenario demonstrates strategic allocation for long shelf-life products batches with 30 days shelf life. The challenge: how do we maximize shelf life utilization across our network with batches ending in B004 and B013? The system prioritizes longer lead time destinations first. For example, batch ending in B004 gets first priority to West Coast Center with 30 days shelf life, have 4-day lead time, arriving with 12 days remaining shelf life from its expiry date, maximizing our long-distance utilization. However, batch ending in B013 with the shorter shelf life of 25 days gets final allocation to the Southwest distribution with 2-day lead time, arriving with 15 days remaining, proving we can serve nearby locations efficiently after optimizing distant ones. This strategic batch allocation maximizes inventory utilization, reduces waste, and ensures optimal distribution efficiency. The system automatically makes these complex optimization decisions, turning shelf life from a constraint into a competitive advantage. The third scenario reveals a hidden supply chain problem: expired inventory inflating our on-hand stock numbers. Since we normally subtract distribution center stock from target quantity to calculate demand, the problem is, what if that distribution center stock includes expired products? Behind the scenes, our system continuously scans every batch at each distribution center, checking production dates against shelf life and best before parameters, automatically flagging and deducting expired units before any replenishment calculations begin. This real-time inventory quality assessment runs every time the optimization engine processes demand, ensuring the distribution center stock numbers you see have already been cleansed of unusable inventory. For example, looking at Northeast Regional DC, you see a target quantity of 2,000 and distribution center stock of only 200, creating a needed quantity of 1,800. But here's what's not obvious. The distribution center stock of 200 is the adjusted amount after our system automatically deducted expired inventory from the original stock levels. Another example is Southwest distribution. The target quantity shows 1,500 with distribution center stock of 300, resulting in needed quantity of 1,200. Again, that distribution center stock of 300 represents only the usable inventory after expired products were removed from calculations. Notice how the replenished quantity matches these higher needed quantity amounts: 1,800 and 1,200 units respectively, both showing 100% fulfillment. Without this expired stock deduction, we would have undershipped and faced stock outs. The distribution center stock column now represents real, usable inventory, not phantom stock that includes expired products. This ensures accurate demand calculations and prevents costly surprises. Pivoting to the demand side, we see the reinforcement learning agents demand forecasting driving complex demand calculations. Specifically for each stock-keeping unit at the distribution center, the orchestrator tests multiple predictive models, like Monte Carlo simulation and Markov, on point of sale, demand data, and selects the best predictor of demand based on the historical date here. It chose Monte Carlo for its ability to model complex, probabilistic demand. We can see how using this model, the calculated historical has a strong correlation to the actual demand. Other models, such as deep Q networks, don't fit the actual demand line as closely, so the system automatically selected Monte Carlo and displayed its data. Having selected the optimal forecasting model, the system is able to derive the average daily demand. Using this number, along with the lead, time, and review period, the system calculates the optimal target stock level for the distribution center and stock-keeping unit being analyzed. With enough sufficient data, we can go a step further and predict demand by week instead of month, showing the different models' predictions at a more granular level. This provides an even more accurate demand pattern. The orchestrator, when run in background, will automatically test the historical demand against monthly and weekly profiles to determine the best time profile for the demand. Based on the historical data fed into the model, the system chooses the best model for prediction, as well as the best time granularity. In this case, the chosen model is Monte Carlo simulation, in an attempt to get the best correlation to the actual demand. The system transparently shows the reasons why each model was not chosen, providing insight into its decision-making process. The distribution map is another essential feature, providing a visual representation of the routes between shipping locations and distribution centers. The line thickness indicates the quantity being moved. Thicker lines mean larger quantities. Finally, once you're satisfied with the plan, you can immediately execute it. By pressing the Publish button, the orders are replicated to the ERP. The optimized replenishment decisions ensuring the right stock reaches the right place at the right time to maximize revenue. As mentioned earlier in day-to-day operations, it is possible to initiate the publication to ERP systems autonomously as part of the background run. Now that we have covered all functionalities of SCLA's SCX, Smart Replenishment Orchestrator, we want you to experience firsthand the precision and reliability that SCLA's SCX brings to your operations by harnessing the power of our advanced intelligent platform that combines reinforcement learning agents, machine learning, and generative AI to deliver optimal inventory management solutions. It empowers businesses to optimize their inventory planning and execution like never before. Join us in turning supply chain chaos into confidence. Visit clas.com and take the first step towards precision.